Hello everyone, welcome back to the channel. So previously we have created videos for how to create a build system like linker file, startup file, and how to create ELF file, how to create a CMake file, all those videos. So this will be common for all projects. So if you are working for any projects, you have to understand all these concepts. In this video, we are going to discuss about LED blinking in STM32F446RE controller. Okay. Our requirement is to blink LED light in PC5 port C, fifth pin, which is connected in the third pin. So I want to blink using this output. And I will take ground from the internal board. Here I'm using Arduino connector. There is a ground here. So I will use this for a ground. I will show the circuit at last. Here the first step is we have to enable a clock for our GPIO pins. So what I will do, I will paste this. So this is the start address of the clock control. RCC means reset clock control. So the start address is 0x40023800. So I'm assigning it into some macro. Then we have to define a port C base address. So here you can see 40020800. This is the base address of port C. So I have defined this. Okay. The next step. Now we have to enable macros for RCC enable register and the GPIO mode registers and ODR registers and all. Okay, let's go back to the technical reference. Here you can see RCC register, and I will go to 30th of offset address, which is the third bit in the AHB1 enable register. So I will add offset as 30. So I have defined it in one macro. Then the second one is mode register. Again, I will go back to my memory address regions. Then I will see the base address and I go to that particular register. Now here you can see this is GPIO A, B and C to H. So for all of this, the offset address is 0x00. So I have to use this offset address plus base address, meaning GPIO C base address plus 0 offset address is equal to mode register. Okay, now we have defined it in the macro. Now we have to define the ODR address, output data register address, which is offset of 14. Now I have to add it in macro GPIO C base plus 14, which enables the GPIO C ODR bit. So I can use these macros for bit operations. So here everything is bit operations. Now first step, I will enable a clock for port C using AH-B1 ENR register, which is third bit in the register set. Okay. Next step is I have to clear the GPIO-C mode register, and then I have to set the output function for this particular pin. Okay. Then we will go to reference manual and we will see how this works. So here you can see bit 10 and 11. So we are clearing those 10 and 11 bit using this bit operation. Then we are enabling general purpose output mode using this R operation. So we are clearing first, then we are enabling output function. Now I will add one more logic, which is ODR bit. I will show it in reference manual first. Using this ODR bit, we can able to change the IOs of that particular pin. So we are using ODR 5 and I'm using XOR operations to toggle the PC5 bit, and I will add some delay functions here so that I can create some delay. So every time it will toggle the bit and it will create a delay and again it will toggle. So it will keep on run so that our LED will get blink. So the steps are like first enable the clock for port C, then clear the mode registers using AND operations, then using OR operations set a mode for output, then using ODR bit toggle the pins. First I will clean my repo, then I will build my source code. Now executable files are created. Before flashing, we will go through the circuit, how we can connect the circuit. So here we want to blink LED using PC5. in LED there are two LEDs. One LED will be bigger size, another LED will be smaller size. The bigger one will be a positive one, the smaller one is the negative one. So we have to give positive supply to the bigger one and negative supply to the smaller one. So the bigger one will connect with positive, which is from microcontroller. So before connecting to microcontroller, we have to use resistance to avoid overcurrent. So use minimum of 330 ohm resistor. So maximum you can use so that your LED won't blown up. And the negative one you can directly connect to the ground which is present in the board. So here you can see there is a ground pin now, which is pin number 6. So you can directly connect ground to LED negative pin. So I have connected negative to the LED pin and the positive. After connecting resistor, this positive line should come to PC5 output pin in the STM32 board. So which is third pin in the connector 10. So I will connect it in the third pin. Okay, now we will flash the software into the controller. Now you can see there is a LED blinking uh, through whatever code we have written. Thank you for watching the video and please do subscribe for more videos. In case if there is a queries, put down the comments in the comment section.